Good morning, astronomy kids. Let's talk about the formation of the solar system and evidence that we have that something happened all at once to form the solar system, and it didn't happen kind of piecemeal. So what's the evidence that we have in our solar system? Well, first of all, if you're going to look at the starry sky and you're wondering where would you look to find the planets, or is that bright thing in the sky a planet? Well, if you're looking along the path that the moon takes through the sky, that the sun takes through the sky, the planets take that path too. It's called the ecliptic. And it turns out, if you view the solar system from the side, the solar system basically looks like this. These are the planetary orbits going around. It's flat. Okay, the solar system turned into a disk. Okay, interesting. If you look at the solar system from the top, you see another interesting pattern. All right, so here we have the sun. All right, and this is if you went above the North Pole of the Earth, you flew way above the North Pole of the Earth and looked down at the solar system from that perspective, you would see the sun turning counterclockwise. Now remember, the sun is 99.8% of all the material in the entire solar system. So the fact that it's spinning that way tells you something about the material that made the solar system. But look at this. Mercury is spinning around it like that. Venus is spinning around it like that. Earth is spinning around it like that. These are all going the same direction, counterclockwise as viewed from above. And now let's look at Earth. Earth is also spinning counterclockwise when viewed from above. All right? We have Mars also going that way and spinning that way. Then we have Jupiter, much further out, huge planet, also spinning that way. Saturn on the planet, Uranus, Neptune, and they're all basically spinning the same way. Now, there are some exceptions to the rule, but for the most part, everything is spinning that way. Why would there be exceptions? We can imagine early in the solar system, things were not so organized, and it was a little bit busier environment with stuff coming through, and there were certainly some collisions, some major collisions. And we think that those collisions probably threw things off. So there are some planets that are tipped more on their sides, but still, the basic geometry of the solar system is this. So we get the idea. We formed from one cloud that collapsed under gravity. As that cloud collapsed, it did a couple things. As the cloud of material that formed this solar system, as it collapsed under gravity, well, some important things happened. We'll talk later about the conditions that have to be inside a cloud in order for it to collapse. Basically, every time the cloud tries to collapse, it heats up. And if that heat can't escape, the cloud can't collapse because the atoms start vibrating faster and they push out. So the cloud tries to collapse, heats up, pushes out. Won't work. The cloud has to get cold enough, about 30 kelvins. And at that point, hydrogen atoms are moving slowly enough they can bond together and form molecules of hydrogen. Why does that matter? Atomic hydrogen is invisible, which means it doesn't absorb light, but it means it also can't give off light. In other words, it can't give off infrared radiation and cool down and let the cloud collapse. So the cloud has to become cold enough to form molecular hydrogen, which is visible. Now it plays with light. So now when the cloud tries to collapse, it can radiate heat in the infrared, and the cloud can keep collapsing. And as it gets warmer, it radiates that heat away and allows the cloud to keep collapsing. That's a really important step in all of this. The cloud has to get cold enough for molecular hydrogen to form. And because a cloud can't cool itself very well, until that happens, it takes upward of 1 billion years for this warm cloud in space to cool off enough to start forming stars. So, serious stuff. As it collapses, does If you have an ice skater spinning and he pulls his arms in, he'll spin faster. Okay, we do that little experiment in class, but as you pull your arms in, you'll spin faster. Well, this cloud is like a light year across, so it has a huge amount of space to come in, and as it comes in, it spins up. And it, of course, all ends up spinning in the same direction. Well, that gets the cloud much smaller and spinning, but now why does it disk? The cloud most definitely disks. So why does it disk? Is it like if you have a lump of pizza dough and you start spinning it, the pizza dough, the outside, has inertial forces which pull it out and make it into a flat pizza? Is it like that? Well, is the cloud all attached with some elastic to all the other parts of the cloud? Nah. So it has to be a different reason. And the reason apparently is that as atoms are colliding with each other, things in the cloud colliding with each other, they average their motion out and they'll drop down to whatever the circular rotation axis is, the center of rotation. So all the cloud collapses down onto that center of rotation. So the cloud disks in that manner. It's averaging out of motion. So why does it disk? It averages out its motion. It's probably the best answer you could give for that. So the cloud spins up, and the reason it spins up is conservation of rotational inertia. And you can say that a number of different ways, but conservation of rotational inertia. In other words, it had this motion when it was way out there, but to bring it way down here, its motion is going to be a lot faster in order to conserve that energy there. And disks is averaging motion. That's mostly collision. You'll realize those two aspects of what happens to this cloud are really important because, yes, it makes a solar system, but when you look at a spiral galaxy, isn't that the same process that has made the spiral galaxy? And yes, it is. So this is what happens when you start forming the solar system. So this answers question 6. Describe the major pieces of evidence for the theory of our solar system's formation. Okay? Everything is in a disk. Everything spins the same way, almost universally. There's a few exceptions that would be from impacts, but all the matter in the solar system acting the same way at this point suggests a common origin. Thanks for watching.